Assalamualaikum warahmatullahi wabarakatuh. Greetings, Mr. Dai and all of my friends. Let me introduce myself again. My name is Helvian Fauzi, Zamier Qoubous, with a student ID 2206055385 from the Numerical Methods Class 01. So here I will be present about the major or grade assignment about the circular economy in engineering problems. So first of all, before we deep dive deep deep dive into the problem, we have to know about the circular economy and economy itself. So this is the overview about the circular economy. So first, an economy is the system of producing, distributing, and consuming goods and services in society, involving interactions between people, businesses, and governments to manage resource and wealth. While a circular economy focuses on minimizing waste and maximizing resource use. So unlike the traditional one, which is take, make, dispose model, the circular economy emphasizes reuse, repair, and recycling to keep products in use longer, promoting sustainability and reducing environmental impact. So here is the uh, so here there is a table about what is differentiate the between circular economy and traditional linear economy or conventional economy. So first aspect is economic model. Circular economy have closed loop regenerative system, while traditional one have take, make, dispose model. And then second aspect is resource utilization. The circular economy maximizes your resource use through recycling, reuse, and repair, while traditional or conventional extracts and uses resource once before disposal. Third aspect is waste management. Circular one aims to design out waste and pollution, while traditional generates waste as a byproduct of production and consumption. Fourth aspect is product life cycle. The circular economy extends product life cycle through maintenance and repurposing, while traditional products have a finite life cycle ending in disposal. And then the environmental impact aspect. So circular economy reduces environmental footprint by minimizing resource extraction and waste, while traditional have higher environmental impact due to continuous resource extraction and waste generation. And then about the energy efficiency aspect, the circular economy focuses on renewable energy and energy efficiency, while the traditional often relies on non-renewable energy sources. And the last aspect is business model. So the circular economy emphasizes product as a service, sharing economy, and remanufacturing, while the conventional one focuses on selling products to consumers for one-time use. Okay, now we get to the main topic, which is the problem in engineering. So we will analyze this problem using the DAI5 concept, which is consists of first intention, and then initial thinking, idealization, and instruction. But before that, however, we must remain conscious of all our actions. So the first step is intention, right? But before that, I want to state a Sahih Bukhari hadith mm, that says, "Innamal a'malu binniyat wa innamal likulli imri'in ma nawa." Uh, that have meanings. Actions are according to intentions, and everyone will get what was intended. So therefore, we must first correct our intentions so that this idea can be beneficial for everyone. So let's get dive to the intention. To identifying the problem that could be addressed. So here I want to say about the problem that is about the plastic in Indonesia. So here there is a data about the increasing of plastic use in Indonesia. So here there is a top source of plastic trash in the world oceans, which is first is China and then second is Indonesia, 3.22 ton to the ocean only. And then four of Indonesia's river rank among the top most polluted rivers in the world, which is Brantas, Wolosrayu, and Progo. That is quite um, irritating. And then here there is the challenges of plastic waste problem in Indonesia. So first is Indonesia generates approximately 6.8 million tons of plastic waste annually, and around 3.2 million tons of it end up in the ocean each year. But only about 3.39% of Indonesia's waste is collected and properly managed, and Indonesia's recycling rate for plastic is relatively low, estimated at around 10%. And then the economic cost of marine plastic pollution in Indonesia is estimated to be between $0.4 to 1.3 billion per year, affecting fisheries, tourism, and cleanup efforts. So this could lead to the consequences. First, it is about the health consequences. So there will be a lot of microplastic threatened. So that can threaten the health of marine life and humans because of the microplastics are it is a cycle. So the plastic waste that is go through the ocean will be solute, and then the fish will be consume it, and we as humans will consume fish, which is yeah, we can accumulate a microplastic in our body. And then from the economic aspect, so that will be decrease in fishermen's income and tourism potential. So because of the microplastic, the population of the fish will be decreased, and then the fishermen's income, of course, will be decreased also, and the tourism potential will be decreased because why would people want to go to a recreation place that have a lot of plastic waste in it? And then third, there will be marine biota. So about 89% of coral reefs contract disease due to plastic contact. So beside that problem, we also have another problem, which is the energy needs are increasing day by day. So, and fossil fuels are becoming the main source of the energy needs. These fossil fuels can increase the greenhouse gas emission in Indonesia, and then yeah, tons amounts of plastic waste dumped into the ocean. So here the idea is to convert it into a valuable energy source. Here is an in-depth overview of the overarching problems that impede then leads to the solution. So there are three main problems, right? First is energy needs are increasing, fossil fuels are becoming the main source. Second is the increase in greenhouse gas emissions in Indonesia, and third is tons amounts of plastic waste dumped into the ocean. So yeah, here we can. So how can we maximize the potential of our energy resources to meet growing energy needs while effectively tackling the problem of plastic waste pollution? So it can be uh, done by converting it into a valuable energy source. So the solutions is processing plastic waste into alternative energy through a technology, namely pyrolysis technology. So we are going to the next step, which is initial thinking. So here we are going to talk about the plastic pyrolysis oil concepts and processes to produce it. So what is exactly a plastic pyrolysis oil? So plastic pyrolysis oil is a alternative source of energy which come from a plastic waste in the ocean that will be transformed into an oil through a technology, namely a pyrolysis. And then what is a pyrolysis? Pyrolysis is a thermochemical decomposition process by heating a material in an inert atmosphere or an atmosphere without the presence of oxygen. So the idea or the fundamental concept of this idea is here I have um, present the picture or graph or picture about uh, the chemical formula from polypropylene, which is plastic, and diesel chemical formula. So the two of those uh, substance have the same uh, the same constructed by the same unsur, which is carbon and hydrogen. So uh, the thing that is differentiate both of them is their structure. So the hydrocarbon structure in polypropylene have different structure in the diesel chemical formula. So the idea is I want to change or transform the hydrocarbon structure in the polypropylene into a hydrocarbon structure that can be found in the fossil fuel. So yeah, that is the fundamental idea. So next is we have the pyrolysis process scheme. So this is the main scheme. There will be a reactor that will be purge the oxygen. So there is no, so there will be just an inert atmosphere. So and then the plastic will go to a conversion chamber or pyrolysis reactor, and then the gas that is from the chamber will go to a condenser, and then the gas tank will be collected in the gas tank. The gas will be collected in the gas tank, and the oil or the soluble gas will be collected in the oil tank. So, and then beside that, there is a plastic pyrolysis oil plant. There is a the more modern one that is used today. And then in below, there is a pyrolysis stages from the plastic waste through a to collection plastic pyrolysis oil. So the first is collection of plastic waste from the fishermen in the ocean and locals. And then we are gonna cut the plastic into small pieces into a powdery phase, and then we will put it in the heating pyrolysis reactor, and then the gas will go to a separate will go to the dusting tower to separate the dust and the gas, and then the gas will be going into a condenser, then it'll be cooled down, and then the cooled down gas will transform into a liquid phase. So it'll be condensing the gas, and then the liquid will be hydrogenated, so it'll be more saturated oil. So it'll be have uh, the characteristic will be more similar with this oil. And then here's the third step, which is idealization. So these are the variables that can affect this pyrolysis process. The first one is temperature. So higher temperatures typically increase the yield of gaseous products, while moderate temperatures are more favorable for producing liquids. And then second, heating rate. So a rapid heating rate may favor the formation of more gaseous products, whereas a slower heating rate can enhance the yield of liquid oil. And then third is residence time. Longer residence times can lead to more complete decomposition and higher gas yields, while shorter times might result in more liquid and solid residues. And then particle size. So smaller particles heat up more quickly and uniformly. Type of plastic, different types of plastic, different have different properties, and then catalyst. So the catalyst will lower the required pyrolysis temperature, and then the last is pressure. So high pressure might favor liquid production, while lower pressure might enhance gas yields. And then the last is instruction. So in the instruction, we'll go to a mathematical equation for solving this problem. So the first one is material and energy balance equation. So mass input equals the mass output plus mass losses. It is the same as the energy. And then there is reaction kinetics equation, heat transfer equations, mass transfer equations, and numerical methods for solving this differential equation. So there is three numerical methods. Equation, the first is finite difference method or FDM. So this will be used to discretize and solve differential equations or PDEs involved in heat and mass transfer. And then second is finite element method or FEM. So it is basically the same. It is another method for solving PDEs, particularly useful for complex geometry and boundary conditions. And then the third is Wunsch-Kutta methods, used for solving ordinary differential equations or ODEs that describe the reaction kinetics. And then the last one is optimization techniques using linear and nonlinear programming. It is used for optimize the pyrolysis process parameters such as temperature, pressure, and residence time to maximize the oil yield and profit. Then yeah, this is so yeah, with this idea and the help of numerical methods, we can help our environment become cleaner from plastic waste and also reduce dependence on fossil fuels, which day by day many negative impacts. This idea also related to and supports the SDGs number 7, 13, and 14, which are among the current concerns of both the government and the world. Okay, I think that's conclusion, and I think that's all for me. Thank you for so much for paying attention to my presentation until the very end. Thank you, thank you so much. Okay, wassalamualaikum warahmatullahi wabarakatuh.